Welcome back from an ad break. So now you're going to be doing some application questions again that are based on compounds. So to begin, we have this question here that says we need to use our periodic table to complete the missing information. So we're given 3 blocks here and the periodic table. So we know that whenever we zoom in on our periodic table, we know that we find the atomic number at the top of the periodic table or of the block, and then at the bottom we have our atomic mass. Then in between those two numbers there must be a chemical symbol. So here we have this atomic number here, which is 15, and remember the elements in the periodic table are arranged according to an increasing in atomic number. So we need to look for atomic number 15 in the periodic table. We count from left to right and go all the way, then we find that it is that one there. So what's the chemical symbol? It is phosphorus with a chemical symbol P. Then our next one, potassium. Potassium, we are given the atomic mass with the name of that particular element. So we can write there that this is phosphorus, so that we don't have any confusions. Then our next one there, it is potassium, and it has an atomic mass of 39. We need to find the atomic number and also find the chemical symbol of potassium. So 39, we know that potassium is a metal that is found in group 1 of the periodic table. So it's found in group 1, 2, 3, 4, and it is also found in period number 4. So this is our potassium with the chemical symbol capital letter K. And then its atomic number, it is going to be 19, because what comes after that, it's calcium with an atomic number of 20. Then we are given a mystery element. We don't know what it is. All we know that it has an atomic mass of 1,007. And I think we know that the atomic mass is given by the number of protons and the neutrons in the nucleus. So if it is 1,007, it means it's almost 1. And that can only be hydrogen that has 1 proton in the nucleus. So if it is 1,007 and we know that rounds down to 1, that means it can only be hydrogen that has 1 proton and 1 neutron in the nucleus. So next question. We need to indicate the number of atoms of the mentioned substances that are present in the compound, and we need to also fill in the table based on the information that is given. So we have our first compound there, NH4NO2. Remember that this 4 and this 2, this 4 is specifically for the H and this 2 is specifically for the O. So then when we are counting the number of oxygen atoms in this particular compound, we have 2 O's. So we have 2 oxygens. And then metals. How many metals do we have in this particular compound, the ammonium nitride? So therefore, we need to start by identifying what we have. We have the nitrogen, we have the hydrogen, we also have the oxygen. The nitrogen is found on the right-hand side of the periodic table, so it's a nonmetal. The oxygen also found on the right-hand side of the periodic table, also a nonmetal. The trick here, or the tricky part, is with regards to the hydrogen. Hydrogen on the periodic table, it is found in group 1, which means that some people might mistake that for a metal, whereas hydrogen is not a metal, it is a nonmetal. It behaves like those elements in group 1, but it is not a metal. So that means in this particular compound here, we do not have any metals. Then how many nitrogens do we have? Like I said, the 4 is specifically for the H, the 2 specifically for the O, so that means we only have 2 nitrogens. So we have 2 nitrogens. Now the next compound, Be3N2. How many oxygen atoms do we have here? There's no O in this compound, so that's going to be 0. And then how many metals do we have on this compound? So we have 2 nitrogens. Then our next compound, it's Be3N2, the beryllium nitride. So it is asking, the question there is asking, how many oxygen atoms do we have in this compound? As you can see, there is no O anywhere on this compound, so therefore that's going to be 0. Then how many metal atoms do we have here? So if you were to look at the periodic table, you find that Be, it is found on the left-hand side of the periodic table, and then N is found on the right-hand side of the periodic table. So Be becomes your metal, and then your N becomes your non-metal. So how many metals do we have? We have 3 of them. Why? Because of that 3 there. Remember that this number, it is specifically for this particular element, and this 2, it is specifically for that one, the N. So we have 3 metal atoms. And then how many nitrogen atoms do we have on this compound? We have just said that this number, it is specifically for that N, so we have 2 nitrogen atoms. Our last compound, FeNO3, and then we have the 3 outside the bracket. So to explain what is happening in the bracket, we have NO3, and then we have the 3 outside the bracket. There's an Fe here. So this is just simply, that means we only have 1 element of iron, so it's only just 1. Whereas in the bracket, anything in the bracket needs to be multiplied by this 3, which then means we're going to have 3 nitrogens, and then with regards to the oxygen, already in the bracket we have 3. So that 3 multiplied by the 3 outside the bracket gives us 9. So therefore we will have 9 oxygens. So to answer this question, how many oxygen atoms do we have? We have 9. How many metals do we have? Remember that iron, Fe, it is found in the transition metals, the big chunk of the elements in the periodic table. That's where we find our Fe, and it is also on the left-hand side, from the metalloids going to the left-hand side. That's where we find our Fe. So how many metal atoms? We said because there's no number here, it is only just the 1. Nitrogen, we've calculated, we said it is 3. Now moving on to our next question, whereby now we're supposed to complete the table by providing either a formula or a scientific name of the given compounds. In some of them we are given the name, in some of them we are given the scientific formula. So we need to check if whether what we're given and provide what is not given. The first one, it is CO. What is the name of this particular compound? So we have one carbon and then 1 oxygen. Remember, we're adding the prefix. So therefore, we'll start by writing the first one in full, and then you're going to add the prefix monoxide. We're adding the prefix mono because you only have 1 oxygen. So this is going to be our carbon monoxide. Then our second one, it is sulfur dioxide. Remember, di means 2. So we have 2 oxygen atoms in this particular compound. The first one is written in full. Remember, this is also a non-metal. Both of these are non-metals. So therefore, it's sulfur. We have sulfur, capital letter S, and then this is going to be O2 for dioxide. And then our next one, we have SiO2. It's almost similar. The difference, remember, if you're not careful, you might mistaken this for the sulfur dioxide. This is a silicon dioxide. Why? Because the Si, it is different from the S. So those 2 different elements have different identities, Si and S. And then the name of this particular compound, it is going to be silicon. Remember the di for the 2 oxygens that we have, dioxide. The oxygen is going to have the suffix IDE and then also the prefix to show how many atoms of that oxygens do we have. Then what we have here, we have sodium nitrate. Sodium is written as Na. The nitrate is going to be NO3. So it's sodium NO3. So that's our particular sodium nitrate compound. Then the last one, CuCl2. So that our first one, it is our metal known as copper. Our second one, it's our non-metal, chlorine. And remember, it must change the ending to IDE. So therefore, this is going to be copper. It's going to be copper chloride. This is our I, copper chloride. So that's what we have up to this point. Now, moving on to our next question and see if whether we can still be able to answer them. Now, give the common name and the scientific name for the following compounds. We have NH3, we have H2O, and then the last one, it is NaCl. We know that NH3, when your parents are asking you to go buy something, they will not say go buy NH3. They will say go buy handy Andy. And we know that it's an ammonia. So this is going to be ammonia, which you know it as your handy Andy. And then we have H2O. We know what H2O is. That is water, what we drink. And then the last one, NaCl, sodium chloride. Now that's what we use when we are cooking to make our food taste a bit better, and that is called table salt. Table salt. We know that this is your sodium chloride. That's your sodium chloride. So before we move on, let us just quickly go drink the H2O, and I'll see you just after this.